Okay, so on my monitor screen right now I can see that we have a vegetable garden over here and I can see a house. Okay, so let us say in this case we have to build certain ways to get from the house to the vegetable garden. Then how can we construct such ways or roads? So let's say to enter this vegetable garden there are 4 gates mainly. There is gate number 1 and 2 right in the middle, and gate number 3 and 4 right on top and bottom. As such, there is no top and bottom in a circle, but let's say if this is my plane surface and these are my direction keys, so this is going to be the top of this vegetable garden and this will be the bottom of this vegetable garden. Now if I have to enter the vegetable garden right from gate number 1, then I can build a straight road from my house to gate number 1, and even we can extend this road right from gate number 1 and connect to gate number 2 as well. Now what about gate number 3 and 4? Okay, so if I construct a road something like this from gate number 3 and another straight road to gate number 4, and then maybe divert those roads towards my house, then yeah, I can say that I can enter the vegetable garden not just from a straight road but even from these roads. Let's name them road A, then the middle one is road B, and the down one is road C, let's say. Now if I carefully notice, my vegetable garden is actually in a form of a circle, correct? And this house that is located somewhere over here is actually like a point that is outside the circle. So if you see, road B starts from the house and it passes through gate number 1 and it touches gate number 2. So I can say it is like a line segment that initiates from an external point and meets the circle at 2 points. So such a line that intersects the circle at 2 points is called a chord. And if we notice road A and road C, what can we comment about them? We can say, unlike road B, they touch the circle at only 1 point. And such a line segment that touches the circle at only 1 point will be called a tangent and not a chord. So that is the main difference between a tangent and a chord. A chord touches the circle at 2 points and a tangent touches the circle at only 1 point. And this particular point where the tangent touches the circle is called the point of tangency. Also, a radius is always perpendicular to the tangent. And by perpendicular, what I mean is that the radius will always make an angle of 90 degrees with the tangent. So a tangent can be identified by 2 things. First of all, that it touches the circle at only 1 point, and secondly that it is perpendicular to the radius. Now let us just change this kind of construction design a bit. Let's just keep road B as it is, and road A and road C, as we know, were constructed straight and then they were diverted towards the house, correct? Let's just say for a second that I need road A and road C to be initiated from the house just like road B. Now after we get such a construction design, what are the things that we notice? First of all, that it has become more convenient to reach gate number 3 and gate number 4 now. Why? Because we don't have to go like this and then divert towards the garden. But just like road B, even road A and road C will serve like shortcut routes towards the garden. And what is the other thing that we can notice? This gate number 3 and gate number 4 have to be moved. And why is that? Because now the point of tangency has been shifted. Now before, this particular point was the point of tangency because roads used to touch this point. Now in this new scenario, gate number 3 has to be constructed like this and gate number 4 has to be constructed over here. And this particular path that was there, which was actually like a radius of this circular garden, will have to be now shifted and we will form a new path now. Now if you will notice, this particular path is the radius to this circle. And even in this scenario, when we have shifted these paths and constructed new gates at new points, even then the radius will always be perpendicular to the tangent. Now actually it is very easier to construct road A and road C. We just have to measure this distance between the house and the garden, right? But let's just make it more interesting and let's say we don't even have any kind of measuring device to just notice this distance. Then what can we do? In that case, we will take help of geometry. As we have learned earlier, geometry helps us to construct any kind of shape very accurately. And before we start this construction, let me just give you the main idea behind the construction. The idea is if we can somehow make a bigger circle, okay, then this bigger circle should pass through our given circle at 2 points. And then with the help of a straight edge, we can join the external point and these 2 points where the 2 circles intersect, and then draw 2 lines. And as a result, these 2 lines will actually be the tangents that we are looking for. So now let us go step by step and learn how do we construct such bigger circle from an external point so that we get 2 tangents. So step 1 in this kind of procedure would be from a given circle, if this is the center, then first we have to join the center to the external point with the help of a straight edge. Let's say we name our external point as P and center as O. So we have a line segment PO. So the first step in the construction is to draw a line segment PO. Now once we get line segment PO, then we will go to step 2 and we will construct a perpendicular bisector. What is the meaning of perpendicular bisector? Well, it is hidden in its name. Perpendicular obviously means that there is an angle of 90 degree that is involved. So this line will actually form an angle of 90 degree with our line segment PO. And if we understand the term bisector, bi will mean 2 and sector will mean portions. It only means this particular line will divide the line segment PO into 2 portions or 2 smaller line segments. So a perpendicular bisector will mean a line or a line segment that is not only 90 degrees but also divides another line segment into 2 parts. And how do we make a perpendicular bisector? With the help of a compass. So we will keep the pointed end of the compass on point O and we will form 2 arcs like this, and then we will keep the point on P as the center and we'll cut these 2 arcs like this. And then with the help of a straight edge, we will join these 2 points of intersection, and the line that we get is actually a perpendicular bisector. But what can we achieve by constructing a perpendicular bisector? Then we can consider either PM or MO as the radius and we can form another bigger circle. Let us see how do we do that. And once we construct a bigger circle, we know that it will intersect our given circle at 2 points. And now we know what has to be the next step. We have to join our external points with these 2 points of intersection. And when we will do that, we will finally get 2 tangents. And they will be tangent PA and tangent PB. But how do we really know if it is a tangent? Well, then we will have to look out for its characteristics. First of all, it should touch our given circle at only 1 point. So we can see our first tangent touches the circle at point A and the second tangent touches the circle at point B. The second characteristic we learnt is that this tangent should be perpendicular to the radius of our given circle. That is, it should form an angle of 90 degrees. So how do we prove if these tangents form an angle of 90 degrees with the radius of our given circle? Any circle can be actually divided into 2 semicircles. Now if you carefully notice this bigger circle, there are actually 2 semicircles in this bigger circle, right? So let us consider first the upper semicircle. And do you recollect one very important property of semicircle? Yes, the property which says that a diameter of the semicircle subtends an angle of 90 degree on the circle. So if we go to see PO, which is our line segment, is actually the diameter of the bigger circle or the diameter of the semicircle. So if you go to see, this diameter has subtended an angle of 90 degrees at point A, and if you notice the other semicircle, even there the diameter subtends an angle of 90 degree at point B. So that actually really explains the reason of making a perpendicular bisector and forming a circle which will touch this external point and also touch the center of the circle. So that's the logic behind constructing 2 tangents from an external point to a given circle.
The complete course for grade 10th CBSE Math is available in Pendrive and SD card format. Click on the link to buy now. To know more, you may also check the description box below.